Alright, in this video we're going to look at another method of finding the height of a triangular distribution. This is using similar triangles, and I think it's an easier method. We sort of need to know the other one first, and then this one is a sort of shortcut that uses the principles of the last one, just a faster way of doing it. Let's have a look at it. Okay, if we look at our triangular distribution, the important one that we're going to look at here is our formula for the major height. Right, because we have two triangles here, and if we do any sort of smaller triangle within it, it's always going to be a similar triangle with it. So if we were to look at something like this triangle here has the same angles at the top, the bottom, and it's the same right angle triangle as the big triangle BC, right? Which means that the ratio between C and B and 2 over B minus A, between this length here and this length here, is the same as the ratio between that length there and that length there. Now that makes this actually work out to be a lot easier to work out when we use that fact. I'll show you how that works. Let's look at an example, and we should make this one work. So we're going to use some nice numbers. For A we're going to do 5, for C we're going to use 10, and for B we're going to use 20. So that gives us some fairly nice numbers. Right, that means our overall height is 2 over 15. And we want to find here the probability that x is greater than 15. Right, so what we're going to look at, we've got three parts to this triangle, three things that we need to look at. So we look at, first of all, we've got this distance here is 5. That's this distance here. This distance here is 10. And we know this distance here is 2 over 15. And what we want to find is this height here. So we know that that height, we're going to call that one h. H divided by 5 equals 2 over 15 divided by 10. Now, while I know fractions isn't everyone's favourite thing, this one actually works out to be reasonably easy to work out, because h over 5, remember when we divide by a fraction, we just put it on the bottom, is 2 over 150. And we can move that 5 up to the top, so we get h equals 1 over 15. Right? Because that 5 goes up here, so it makes it 10 over 150, which is 1/15. And immediately we found the height. Now that's a whole lot easier than putting it into the formula and going through that. And so then if we wanted to find the probability, 1/15 times 5, which is 1/3, times a half is 1/6. So we could do that pretty easily. The probability that x is greater than 15 equals 1/15 times 5 times 1/2, because base times height times divided by 2, right? And that equals 5 over 15 is 1/3, 1/6. That's all there is to it. So what I want you to do is have a go at using, and once we find the heights, we can then work out the areas for some more complex shapes by subtracting and all sorts of things. It all works. So here's the task that I want you to do with this one. Alright, here's a story. Melanie likes croissants. She eats them quite often. She realized that she always eats at least 6 every week. She probably should watch her diet. The most she's ever eaten in 1 week is 30. The most common number of croissants that she eats in a week is 10. Find the probability she eats less than 15 croissants in a given week. So I want you to try using triangular distribution for this. Obviously we've got a max, a min, and a mode. And have a go at using the similar triangles method to find the height.